Hello students, welcome to Probability Theory class. I am Mrs.K.GLORY Prasanth, Assistant Professor, Department of Mathematics, S.A.ENGG Engineering College. So in this class we are going to discuss the basic concepts and solve previous year question papers of GATE examination in probability. Now let us move on to the basic terminologies in probability. The first concept is random experiment. So an experiment is called a random experiment if when conducted repeatedly under essentially homogeneous condition, the result is not unique but may be any one of the possible outcome. For example, tossing of a coin is a random experiment because if we toss a coin, we may get head or tail. But we are not sure which one will appear. The next concept is trial and event. Performing of a random experiment is called a trial, and the outcome or combination of outcomes are termed as events. Example, tossing of a coin is a trial and getting head or tail is an event. Similarly, tossing of a die is a trial and getting any one of the faces 1, 2, 3, 4, 5 and 6 are events. The next concept is sample space. All possible outcomes of a random experiment together constitute a sample space. So example, if we toss two coins, the possible outcomes are HH, HT, TH, TT. Okay, so the sample space is nothing but S. The sample space which is denoted by S is nothing but HH, HT, TH and TT. So this is our sample space. Always remember sample space is denoted by S and it is represented, the outcomes are represented within a curly bracket. The next concept is exhaustive cases or events. The total number of possible outcome of a random experiment is called exhaustive number of cases. Example, if we toss two coins, the sample space S is equal to HH, HT, TH and TT. So this is our sample space. Now, so in this, the exhaustive number of cases is nothing but 4. How do I write the exhaustive number of cases as 4? Why? Because the number of possible outcomes are 4. So therefore, the exhaustive number of cases is nothing but 4. The exhaustive number of cases is represented as N of S. The next one is favorable events or cases. The number of outcomes of a random experiment which entails the happening of an event is known as cases favorable to the event. For example, if we toss two coins, this is our sample space. So the case favorable to the event of getting exactly one tail is 2. How do I get this 2? See, if you look at your sample space, exactly one tail. How many one tails are there? HH, HT. So only 2. So therefore, the case is favorable to the event is nothing but 2. Right? The next one is mutually exclusive events. 2 or more events are said to be mutually exclusive if the happening of any one of them excludes the happening of all other in the same experiment. So for example, if we toss a coin, we may get head or tail. So both the events head and tail are mutually exclusive because if head comes, we cannot get tail. If tail comes, we cannot get head. Now approaches in probability. There are three approaches in probability: classical approach, empirical approach and axiomatic approach. Now let us look into the three approaches one by one. Classical approach. So classical approach states that if a random experiment results in n exhaustive, mutually exclusive and equally likely events, out of which m are favorable to the happening of an event, then the probability of occurrence of an event A is given by P of A is equal to favorable number of cases divided by the exhaustive number of cases. Next is empirical approach. So empirical approach states that if an experiment is performed under homogeneous and identical condition repeatedly, then the limiting value of the ratio of the number of times the event occurs to the number of trials become indefinitely large is the probability of happening of an event A. It is being assumed that the limit is finite and unique. Now let us see the probability of happening of an event, how it is being represented. It is being represented as P of A is equal to limit n tends to infinity m divided by n. So the next approach is axiomatic approach. It's a very important approach. So there are three axioms under the axiomatic approach. The first axiom states that if A is any event, then P of A is defined, real and non-negative. So that is, how do we represent this? As P of A greater than or equal to 0. The first axiom is also known as axiom of non-negativity. The next axiom states that probability of a sure event is 1. That is, P of S is equal to 1. So this axiom is called as axiom of certainty. The third axiom states if A1, A2, A3, etc. up to AN is any finite or infinite sequence of disjoint events of S, then P of union I is equal to 1 to n AI is equal to summation I is equal to 1 to n P of AI. So this axiom is known as axiom of additivity. So this is very important approach of all the three. The next concept is probability formula. So in probability formula, we'll look into the events in probability and then the different probability formulas. So what is meant by events in probability? So in probability theory, the event is nothing but set of all outcome of a random experiment. To be in simple term, event is nothing but a subset of a sample space. Right? Now, if P of E represents the probability of an event, then we should have a P of E is equal to 0. If and only if E is an impossible event, P of E is equal to 1. If and only if E is a sure event, then P of E should be less than or equal to 1 and it should be greater than or equal to 0. So if E is an event, then the probability of an event can satisfy any of these conditions. Now different probability formulas. We'll move on to the different probability formulas. So in that, the first one is addition theorem of probability. So this theorem states that if A and B are any two events and are not disjoint, then P of A union B is equal to P of A plus P of B minus P of A intersection B. Okay. Then the next one is complementary rule. Whenever an event is complementary of another event, especially if A is an event, then P of not A is equal to 1 minus P of A. So in notation, we can represent it as P of A dash is equal to 1 minus P of A. Now when you bring this minus P of A to the left side, it will become P of A plus P of A bar is equal to 1. Okay, so this is again a very important rule. The next rule is conditional rule. In conditional rule, we have two conditional probability. The conditional probability of B given A, then a conditional probability of A given B. Now let us look into the conditional probability one by one. The first one is conditional probability of B given A. So the conditional probability of B given A is nothing but the probability of occurrence of an event B when the event A has already happened. And how do we denote it? We denote it as P of B given. So this is nothing but given. You should write like this. It should not be written like this. This is wrong. So given means it should be a straight line. So P of B given A is equal to P of A intersection B divided by P of A. Next, the conditional probability of A given B is the probability of occurrence of an event A when the event B has already happened. So in such case, P of A given B is represented as is equal to P of A intersection B given divided by P of B. Now next, multiplication rule. So whenever an event is an intersection of two events, that is, if event A and B need to occur simultaneously, then P of A intersection B is nothing but P of A into P of B. When does it happens? When the events are independent. Very important. This is very important concept. P of A intersection B can be written as P of A into P of B if the two events are independent. Next, if the events are dependent, in such case P of A intersection B can be P of A into P of B given A or P of B into P of A given B. Now let us solve previous year question papers of GATE examination. The first problem is a fair coin is flipped twice and it is known that at least one tail is observed. The probability of getting two tails. Suppose the question is a fair coin is flipped twice. Only that is mentioned in the first sentence. Then your sample space will be HH, HT, HH, HT, TH and TT. Suppose you have a sentence, a fair coin is flipped twice, but you have in the question additional to that one condition is given. It is known that at least one tail is observed. So at least one. What is meant by at least one? Greater than or equal to 1. So they have given a condition. You should select a sample space such that it should possess at least one tail. So here this does not have tail, so you should remove this from the sample space. This has one tail, here also one tail, here it is two tail. So your sample space S is nothing but HT, TH and TT. So now your exhaustive number of case, which is denoted by N of S, is 3. Next, we'll move on to the event. What is our event? Event is nothing but getting two tails. So A is nothing but an event of getting what? Two tails. So what is your A now? Getting exactly two tails. It is nothing but only one option, which is nothing but TT. So your favorable number of cases is nothing but only 1. Now let us find the probability of getting two tails, which is nothing but P of A And P of A, the formula is what? Formula is favorable number of cases divided by the exhaustive number of cases. Favorable number of cases is denoted by N of A and exhaustive number of cases is denoted by N of S. So N of A is 1, N of S is what? It is nothing but 3. So here the option A, 1 by 3 is a correct answer. Now we'll move on to the next question. A fair die is rolled twice. Understand the question first properly. A fair die is rolled twice. The probability that an odd number will follow an even number. So, first of all, we'll identify how many events are there in the problem. How many events are there? There are 2 events. One is getting an odd number, another one is getting an even number. So, let us denote the 2 events as A as getting an odd number, B as getting an even number. So in question we are talking about 2 events. One is getting an odd number, another one is getting an even number. So we are talking about this. Now what the nature, next step is we need to find the nature of the event, because nothing is mentioned in the question. They have just asked us to find the probability that an odd number will follow an even number. The nature is not given, you need to find the nature. So what is the nature of this? See, odd number and even number. We are talking about odd number and even number, which means that A and B are independent. Are independent events. Okay, so this is the meaning of it. A and B are independent. So this is what we got from the question. Now we have to solve the problem. To solve the problem, first we need to write the sample space. A fair die is rolled twice. What is the meaning of it? When you have to read the first sentence and the second one, and then you have to incorporate. See, a fair die is rolled twice. The probability that an odd number will follow an even number. So first you are taking a die, you are rolling it, you are getting an odd number. Then again you are taking the same die and again you are rolling it, you are getting an even number. So your sample space, so you are talking about only one die. So your sample space S is nothing but 1, 2, 3, 4, 5 and 6. So this is your sample space. Now what is A? A is nothing but an event of getting an odd number. So now find your probability of this getting an odd number. What is the probability of getting an odd number? What are the odd numbers here? 1, 3 and 5. So you have 3 numbers out of how many? Out of 6. So now this is nothing but 1 by 2. The next event is B, which is nothing but getting an even number. So what is the probability of getting an even number? Again, what are the numbers here? 2, 4 and 6. So how many numbers? 3 numbers out of 6. So this is again 1 by 2. Now we have found from the question A and B are, we found the nature to be independent. The 2 events are independent. So independent, if it is independent, we saw in multiplication rule, what will happen? P of A intersection B is nothing but P of A into P of B. What is your P of A? 1 by 2. What is your P of B? It is also 1 by 2. So this is nothing but 1 by 4. So your answer, correct answer is D option, 1 by 4. The next problem is a fair coin is tossed 10 times. So you are taking a coin, how many times you are tossing it? 10 times you are tossing it. What is the probability that only first 2 toss will have head? So which means that you have 10 tosses. In 10 tosses, only the first 2 will get head. The remaining all will be the tail. So this is what we got from the question. Again I am repeating, a fair coin is tossed 10 times. So you are taking a fair coin, it is being tossed 10 times. You have to find the probability the first 2 tosses will yield head, which means that only the first 2 will yield head, the remaining will yield tail. Remaining 8 tosses will be tail. So now when a fair coin is tossed, what is the probability of getting head? Only there are 2 options. When a coin is tossed, what are they? Head and tail. Head and tail. So probability of getting a head. So probability of getting a head is nothing but 1 by 2. So similarly, probability of getting a tail is what? That is also equal to 1 by 2. So when a fair coin is tossed, immediately it should come to your mind that probability of getting a head is 1 by 2 and the probability of getting a tail is also 1 by 2. Now what did we ask us? Probability that only the first 2 tosses are head. So first 2 toss. The first 2 toss means 1 by 2 into 1 by 2. So it is 1 by 2 the whole square. The remaining 8 tosses is what? It is nothing but a tail, and that is also 1 by 2. So 1 by 2 occurs how many times? 8 times. So this is nothing but 1 by 2 the whole power 10. So the correct option is C option, 1 by 2 the whole power 10. Now next, an examination consists of 2 papers, paper 1 and paper 2. The probability of failing in paper 1 is 0.3 and that in paper 2 is 0.2. Given that a student has failed in paper 2, the probability of failing in paper 1 is 0.6. The probability of a student failing in both the papers. So you have to understand sentences, you have to understand each and every sentence and then you have to solve it. The question looks big, but it is very simple if you understand the sentence. See, look at the first. See, if you read the statement, we are talking about only 2 events. The first event is failing in paper 1 and the second event is failing in paper 2. So we are talking about only 2 events, failing in paper 1 and failing in paper 2. So these are the 2 events we are talking about. So let me write that. Let A be an event of failing in paper 1. B be an event of failing in paper 2. So first step is you have to identify how many events how many events are mentioned in the question. There are 2 events, failing in paper 1 and failing in paper 2. Let me take A as failing in paper 1 and B as an event failing in paper 2. Now, what else is given? The probability of failing in paper 1. So probability, they are talking about probability, which means that P of A is equal to 0.2. 0.3. Not 2, it is 3. Next, they are talking about the probability of failing in paper 2. What is that? It is nothing but 0.2. The next statement says that given that a student has failed in paper 2. Given means, I said, you should put a line like this. So given that a student has failed in paper 2. So the student has failed in paper 2. The probability of failing in paper 1. The probability of failing in paper 1. So understand how do I write it. So first what I'm doing is I'm writing given. I'm just putting a slash. So given that a student has failed in paper 2, so which is nothing but B, the probability of failing in paper 1, so probability of failing in A is equal to 0.6. So this is what given to us. Now P of A is given, P of B is given, P of A given B is given to us. Now what you need to find? The probability of a student failing in both the papers. What is meant by both the papers? Both means and. So which is nothing but intersection. So whenever you have intersection, it means that and. So P of A intersection B. This is what you need to find. So you need to find P of A intersection B. So we saw in multiplication rule the dependent event. So P of A intersection, because this is not an independent, this is a dependent event. P of A intersection B is nothing but what's the formula? P of what is given to us? P of A given B into P of B. Actually we have two formulas. These are the two formulas which we saw in multiplication rule, but this is not applicable. Why this is not applicable? Because we don't know what is P of B given A. We know only A given B. So this is not applicable, only this is applicable. So what is P of A given B? It is nothing but P of A given B is nothing but 0.6. And what is your P of B? It is nothing but 0.2. So the answer is 0.12. So the option C is correct. Now the next is, for two events A and B, B contained in A, which of the following statement is correct? Okay, so now we'll do this. Now what is given to us? They have given us two events A and B contained in A. So first let us create a sample space. Yes, an event A, an event B. Now why do I write B inside A? Because of the concept B is a subset of A. B is a subset. You can even call it as B is contained in A. Now we know that A intersection B is nothing but B. Now take probability on both sides. P of A intersection B is equal to P of B. Now divide both sides by P of B. P of A intersection B divided by P of B is equal to 1. So this is nothing but P of A given B is equal to 1. Okay. Now if you look at this, now if you look at this, P of A given B is 1, which means that this is not applicable because P of A given B is equal to 0, and even this is also not applicable because P of A given B is less than 1. So now we have to check for the other two conditions. Now let us consider P of B given A, which is nothing but P of A intersection B divided by P of A. What is P of A intersection B? It is nothing but P of B divided by P of A. Now I need to check P of B given A relation with P of B. In both the cases, either A will be correct or C. Any one option will be correct. So what you need to check now, this should be P of B given A should be checked with P of B. Now I need to find the relation between these two. Now we know that the probability value will lie between what? 0 and 1. Let us consider P of A to be equal to, let us consider P of A is equal to 1 by 2. So we have P of B given A to be P of A intersection B divided by P of A. This is nothing but P of B divided by P of A. Okay, now we need to find the relation with P of B. So suppose I substitute here, substitute P of A is equal to 1 by 2. What will happen? It will become 2 times of P of B and here P of B. So definitely this will be greater. Suppose I choose P of A. Suppose I choose P of A as 1. So what will happen? It will be equal to P of B. So P of B given A will be greater than or equal to P of B. So which means that the first option, P of B given A is greater than or equal to P of B, is a correct option. Okay. So with this we end the session. We'll continue in the next section.